If you are currently leveling up your Django and Postgres skills with this tutorial, you might like to know that this tutorial is part of a whole playlist where you will learn how to, with Django and Postgres, create database level constraints and triggers. If you like this playlist and you would like to learn more about Django ORM, then do check out our Django ORM Mastery course on Udemy. Links to the playlist and course can be found in the video description. Okay, so next up, Docker, introducing Docker. So whether you're on Mac or Windows, it's going to be the same process, or we're going to work with Docker in a very similar way. The only difference between Mac and Windows will be the actual installation process. This tutorial is for anyone who is new to Docker. So in this tutorial, I'm going to take you through the installation process, the setup, and then first steps. So we're going to have a look at some of the underpinning skills and knowledge that is needed to start working with Docker. If you're not new to Docker, you just need to have Docker installed and you can move across to the next tutorial. So first of all, I did lie a little bit. I don't have an installation guide because it is so simple to install. All you need to do is, or one way you can do this, is just type in Docker installation into Google. Click the top link, install Docker, select the platform that you're working with, and Docker is installed. Now I say that simple process. Yes, so Docker desktop for Linux, Mac, Windows is at the top here, and anything else is below. So you can go ahead and go through the installation process. For Mac, I simply need to select Apple or Intel chip. So make sure you do download the correct version. So I'm using Apple Silicon. So I simply download it, go through the process, click next. There isn't really, for Windows or Mac, any additional information I can give you or selections to choose. Just go through that process, install, and you should be good. Right, so once you have installed Docker or Docker Desktop, you will now need to open Docker and you'll be presented with something that probably looks a little bit like this. So straight away, what you'll notice on the left-hand side, you have volumes, images, containers. So let me just quickly and very briefly take you through what that means. So first up, why use Docker in the first place? Well, developers tend to use Docker primarily for its ability to create consistent and reproducible environments across different platforms and development scenarios. So Docker simplifies the setup and management of development environments by packaging applications and their dependencies into lightweight containers. If I were just to translate that, we could translate that as this. Instead of installing Postgres onto our local machine, we can install Postgres into a container in Docker. And that's going to help us really be much more productive. It's going to make it easier and more efficient for us to work with Postgres than if we were to actually install it locally on our machine. So let's start here, Docker Hub. So I've typed in Docker Hub into Google. Docker Hub is a cloud-based registry service provided by Docker. So this allows developers and others to share, store, and manage Docker container images. Right, so this serves as a centralized repository where we can find public Docker images for popular software applications. So let's go into Docker Hub, and I'm going to type in Postgres database, and here what you can see is the official Postgres image. I know it's the official image. It has a little icon here denoting the fact it's a Docker official image, so we can trust that. So be careful to try and always choose the Docker official images. You can filter them out. Right, so you can see this is quite popular, over 1 billion downloads. So let's have a look at this. Right, so this is a pre-created image, which ultimately is going to be converted or turned into a container so that we can actually run Postgres database, and our Postgres database will then run in that container. So what you're going to find here is that there's lots of different versions of this software. So here you can see these different versions here, and we can utilize this to match the version that we want to use to our particular project. We might want a more slimline version because we don't need all the features maybe, or you might want to use the whole thing. So you'll need to become familiar with these different types of tags as and when you get a little bit deeper, but ultimately you can just use the latest. There's a kind of latest option here, or we're going to be using a slightly slimline version. That means less downloading originally. So we're going to be utilizing this Alpine version, which, like I've said, is more of a slimline version of the image and Postgres database. So life starts off here as a Docker image. This is a lightweight, standalone, executable package that includes everything needed to run a piece of software, including the code, runtime libraries, dependencies, and any configuration files. So we are going to be downloading the Postgres image. That includes everything we need to start running Postgres database on our system. So from this image, we're going to build a container. Okay, so from this image, we are going to be building a container. A container is a lightweight, isolated environment that encapsulates an application and its dependencies, allowing it to run consistently across different computer environments should we choose to. So essentially, from this image, Docker is going to build a container. So if you think about the image as the startup disk for something, then it's going to basically take all that information, and from that it's going to build a container. So within our container, we are going to have the Postgres database running, ready for us to utilize. Now, one of the issues that we might have is with a container is that when the container is active, then everything is absolutely fine. All the files are there, and so on and so on. So let's imagine we have a Postgres database in our container. We start to add data to our database. Now, one of the problems that we might have is that we remove the container, everything is destroyed. So data is not persistent. So what we're going to potentially need, one of the tools that we can utilize, is a volume. So a Docker volume is a mechanism that allows us to persist data beyond the lifetime of the container. So it provides a way to manage and store data separately from the container's file system. This ensures that obviously our data persists even if the container is stopped or removed. So going back to our interface here, that's exactly what we're looking at. So when we download images, we're going to find them right here. So we can actually search and run for images right here in actual fact. So I'm going to select Postgres. Let's go ahead and select Postgres. We can go ahead and pull it down. So let's just go ahead and pull that down. And what's happening now, of course, is we're downloading that image from Docker Hub. So that's going to download and finish. If I go back into my images, once that's done, we're going to find that it will appear right here. So once it's finished downloaded, you can see that we now have this image. So what we can go ahead now and do is to run it. So on the right-hand side here, you can see we have a run icon. So I can click that, and I will need a few different settings for this. This isn't going to necessarily work correctly, but the idea is that we press run here and then our container starts. So we've gone from our image, we've run our image, that has now built a container. So you can see this is our container right here. You can see it hasn't worked correctly because there are a few parameters that we need, but this is the general workflow. So that's our container right there. We can go ahead and remove this container when we've finished with it. And you'll notice also there is a volume here as well. So it looks like by default, a volume has been created for the container we've just created. We can go ahead and manage that by deleting that volume. For the duration of the course, we'll try and utilize Docker Desktop as much as possible. It is a great user interface for us to interact with our images, volumes, and containers. But we will now and then utilize commands to perform operations in Docker. So I will, as and when we get to that point, I'll provide more information and we'll go through that. But like I said, we'll try and utilize Docker Desktop as much as possible because it's a nice intuitive interface for us to manage our containers, images, and volumes. So I hope that's given you a general overview of volumes, images, and containers. Our goal shortly will be to create a Postgres database container so that we can connect our Django application to that Postgres container so that we can start to utilize that software for our Django project setup. Now, as you saw previously, it is possible for us to download the images from Docker Compose. Generally, that's not how we create a setup for our project. Generally, we're going to be utilizing two types of files, or including two types of files, artifacts within our project. That's going to be a Docker file or a Docker Compose YAML file. So the Docker file generally is a text-based script that contains a series of instructions used to build a Docker image. So generally, the Docker file is all about building an image. Because what we might like to do, for example, is grab an image from Docker Hub. We might want to make some changes to it and then build a new image from that. That's a very common process. So we have the base image that we're going to download from Docker Hub. And then what we do, like I said, is make those changes and then make a new image from after we've made those changes to the initial image that we've downloaded. So think of Dockerfile now as a way of developing the image in preparation for it to then be utilized and to start a container. If you like, you can think of it as a blueprint for defining the steps needed to create an image that includes all the necessary dependencies, configuration, and runtime environments for a specific application or service. Okay, so now we have the Docker Compose file. So Docker Compose file, typically a YAML file, this is used to define multi-container Docker applications, because it might be that we don't only want to have Postgres database, we also maybe want to use pgadmin, which is an administration package that we can use to administrate our database. And we might want that in the same project. So Docker Compose is one of the things it's going to do is going to help us or allow us to configure multiple Docker containers that we want to build as a single application. Inside of our Docker Compose file, we would also include some of the different configurations that we're going to need to actually start the images as containers. So we might want to define not only the services, the images that we want to use, but also networks, any volumes that we want to use, and any other configurations required to run the application. So in general, let's think about the Docker file as a way of creating the image and the Docker Compose file as a way of defining the configurations required to actually run the application. So hopefully that's given you a general idea of what Docker is, how we're going to be utilizing it within our project. Ultimately, Docker is going to allow us to install, run, manage the Postgres software on our computer without having to actually install it on our machine.